Okay, so the last problem of this section, problem 30, asks a researcher measures the initial rate of V0 to delta equals delta P over delta T of an enzymatically catalyzed reaction in a variety of substrate concentrations. And so the reaction S to P, the enzyme, tells us that initially, this would be linear, and they ask which graph is best with the observed relationship between the concentration versus V0. All right, so what's going to happen as this goes on, as this reaction goes on? All right, it's going to start out there, and there are four graphs to choose from. Of course, it starts out linear. The first graph looks like this. The second graph looks just like that. The next graph looks like that, and the final graph is decreasing. Right. So we can sort out that V0 decreasing. It's not the answer. We can eliminate that one right away. So the next question is, what's going to happen? Well, as you take substrate concentration out, right, as S goes to P, there's less and less S to convert. So the last thing you would think to have happen would be for it to speed up, right, simply because there's less and less to convert as you go on. And in fact, you eventually have to reach a point where the conversion goes to zero because you've converted almost all of it. So you also wouldn't expect it to be linear the whole time. What you would expect is for it to approach some asymptotic maximum, like here, and that's part A. So the answer in this, the answer is A, right? You're going to need to look at the graphs in your book to see everything a little bit better, but the answer is A. As you take S out of, as you convert S to P, you have less and less S to convert, and your asymptotic going to approach some maximum value. And that's the end of that problem.